Hey guys, another chapter 4 video here. I still currently have my broken leg, if you heard that in the last video. So I am crutching around and stuck on the couch, so lots of time to make these math videos. Here's the question for this video. How do I find parallel lines? How do I find parallel lines? So we're going to dive into this with a problem. We're going to do an example 1. And the focus here is we're trying to become these experts at knowing how to write equations for lines, graph lines, make tables, but we also want to know about how to compare different lines to each other. So let's get into what a parallel line situation would be. So here's what we're going to do. We're going to graph a system, and we are going to graph two equations. The first equation is one that doesn't really bother me. It's y equals 2/5 x plus 1. The reason I say it doesn't really bother me is it's in a nice format. I see it as y equals mx plus b, and I think it's going to be very easy to graph. Y equals 2/5 x plus 1. But the second equation looks a little bit more challenging to me. It's 5y minus 2x equals negative 20. It's in standard form, and I don't really like standard form because I don't see the slope in the y-intercept right away. But we can fix that. We can fix that up. Let's grab a ruler. And let's start sketching a graph in our notes and making a nice clean XY axis with our scale numbers. I'm going to go big. I'm going to go up to 9 and down to negative 9, basically 10, out to 10, back to negative 10. So pause the video, set your notes up nice, make a good looking graph. I think when I start this graph, I'm going to go with the easy one first, the y equals 2/5 x plus 1. Because of the plus 1, I already know where to put a point on the graph. I'm going to put my y-intercept at 1. And because of the 2/5, I already know my slope. My rise is 2, my run is 5. So I'm going to go up 2 over 5, put a point. And then I could keep doing this. I could go up 2 over 5, up 2 over 5, but I don't really need a lot of points. I'm going to grab a ruler, connect my 2 points, and make a line. Okay, there's the first line. Let's do the second line. Second line's in standard form. Yuck. So I'm going to put a line down the middle. I'm going to solve for y, and I'm going to change it to y equals mx plus b. I'm going to take that 2x and move it to the other side, make it a plus 2x. I'm going to keep the 5y, and then I'm going to make it 2x minus 20. Now let's divide the 5 away. We got to divide everything by 5. That gets rid of the 5 from the y, which is what I wanted to do, but it leaves me with 2/5 x, and then minus 20 divided by 5. So I'm going to have this 2/5 x minus 20 divided by 5 is 4, so minus 4. Okay, now it's graphable. Y equals 2/5 x minus 4. I'm going to start at negative 4 on my graph and put a point. And then I've got that slope, 2/5. That's my rise and run. So I'm going to go up 2, oh, sorry, I lost my point, up 2 over 5 and place a point. And then I could continue doing this. I could go up 2 over 5, up 2 over 5. But I'm happy. I'm going to take my ruler, connect my line, and make it happen. So there it is. Okay, look what we got. We got parallel lines. We got two lines that have the exact same slope. Did you notice that? 2/5 was the slope for the first line and the second line. And these lines are never going to intersect. They're never going to cross each other. They're going to go side by side the whole way up the graph without ever crossing. So let's write that down. That's kind of a big idea for the side of our notes today. Parallel lines. They never intersect. They never cross each other. They're like railroad tracks going side by side. So that's kind of a key feature. And the algebra thing to write down that is so important is they have the same slope, the same rise and run. That's what makes them parallel. So parallel lines always have the same slope. I want you to get that stuck in your head. And I'm going to, on the graph, kind of highlight that by showing that growth triangle. Remember the growth triangle was up 2 over 5. It's the same thing on both lines, up 2 over 5. You should add that to your graph if you haven't already done that yourself. Okay, so you try. I'm going to give you a question here. Are these two lines, I called them A and B, are lines A and B parallel? How do you know? Take a minute, Pause the video and see if you can answer this question. Okay, so you're hopefully unpausing the video, and we're going to see if these lines are parallel. So for line A, the first line, I'm looking at the slope and thinking in my head it's 3/5. I see the y equals mx plus b, I see the m, I see the 3/5 slope. So I know on the graph, if I go to graph it, it goes up 3/5. Now maybe you already graphed it when you pause the video. Watch what I'm going to do. I'm going to put a line down the middle of the other equation, the standard form one that we don't like, and I'm going to solve for y. I'm going to add the 3x over. You maybe did this too. I'm going to get 5y equals 3x minus 10, and then I'm going to divide the 5 away to get rid of the 5. And look what I'm left with. A 3/5 x minus 10 divided by 5, which is 2. So 3/5 x minus 2. Now I could go graph this, but what do I know? I know the slope of this line B is 3/5. So I already know the slopes of line A and line B and that they're matching. They're both 3/5 and 3/5. So yes, I could go graph this, but I don't have to. I already know these are parallel lines. Both lines have a slope of 3/5, therefore they must be parallel. I'm going to write that down. Here's a way of proving two lines are parallel without looking at the graph. Now I'm writing this statement down here. Both lines have the same slope of 3/5, therefore they must be parallel, because I want whoever grades my work and looks at my paper, I want them to know I really understand this problem. Now if you took the time to graph this, if you had this work and a graph, it's probably your level 4, like that would be kind of your advanced grade right there, because you're tackling this problem visually and algebraically, so you're doing the graph and the algebra. So keep that in mind. Like if you had time on a test or something, yeah, I would graph it also. But if you didn't want to graph, you wouldn't have to. You could just look at the slopes. Okay, so here's that graph. I'm going to add it onto here because I have a feeling many of you probably did graph it when you paused the video. So hopefully your graph has the two parallel lines kind of just like the previous example we did, never intersecting each other. Okay, let's try another example. Example 2. Which of these lines are parallel? Which of these lines are parallel? Line A, line B, and line C. Now I'm going to give you some facts. I'm going to tell you what points these lines pass through. So I'm going to tell you what line A passes through. I'm going to tell you what line B passes through and what line C passes through. So here you go. Here are the coordinate points. Pause the video, write them all down so you have them. So there's two ways I could do this problem. One, I could graph it. I could get a graph out, plot the points and connect them with the lines, and then I could look to see which ones are parallel. Or I could skip graphing and just find the slopes. And I think that's what I'm going to do. I'm going to skip graphing for the moment and I'm going to find some slopes. Now when you have 2 points, how do you find slopes? Well, you need rise and run. You need delta y, delta x. So we're going to jump in and we're going to do our delta y, delta x formula. And we're going to label our points the x1, y1 and the x2, y2. Something we have already learned in class. This is not the first time we've done this. So our delta y, delta x is going to be, for the first line, -1, take away 3. That's the y2 minus y1. And on the bottom, it'll have to be -6, take away -5. So we'll do our math. -1 take away 3 is a -4. -6 plus 5 is -1. And then 4 divided by 1 is 4. And a negative divided by negative is a positive. So did a little bit of work there, but our slope is 4. Now we got to repeat that process for line B and line C. So each time I'm going to label these points x1, y1, x2, y2. Then I'm going to do my delta y, delta x. I'm going to subtract the y values on top. -7 take away -2. I'm going to subtract my x's on the bottom. 2 take away 3. And then I'm going to do my math. So -7 plus 2 is -5. And 2 take away 3 is -1. So 5 over 1 is 5. Positive 5. Negative over a negative is a positive. Now we got to do line C. Same thing. x1, y1, x2, y2. We're going to do delta y, delta x, and we're going to subtract the y values. We're going to do the -2, take away the 10. And we're going to do the 4, take away the 7. and that would be negative 12 and negative 3. Now when you divide those, 12 divided by 3 is 4, and a negative divided by a negative is a positive. So we're done. We got our slopes. We got a slope for A is 4, slope for B is 5, slope for C is 4. So now that we have that figured out, here's what we know. Matching equal slopes means parallel lines. So we look like we got line A and line C that are parallel, and we're going to write that down. Line A is parallel to line C. They both have the same slope. Now, if you felt like graphing and drawing a big graph and plotting the points and showing the lines, hey, that's a great strategy. It's your level 4 work, really. So there's nothing wrong with doing that. But just kind of keep in mind, you don't have to graph every time. Here's another way you can write your answer also. This is a shorthand notation that you're going to use in geometry class. It reads A is parallel to C, but the way it looks is it's just these two double lines. A is parallel to C. It's just a shortcut way of writing that sentence. Just another notation you should be familiar with. Okay, it's your turn. Time to try. You're going to pause the video here in a second. Your question is, which of these lines, if any, are parallel? And there's a line A, a line B, and a line C. Okay, hit the pause button. Go ahead and try this. See if you have this down. Okay, guys, we're going to check your answer. Let's see if you have this down. So we're going to check each line. For line A, delta y over delta x is going to look like this. You have a slope of 1/2. Hopefully that's what you got. For line B, your delta y delta x is going to look like this, and you have a slope of negative 3/2. And for line C, your delta y delta x gives you a slope of 1/2. Now, if you need to pause the video and kind of go through your solutions, you should check and see if you made any mistakes in your delta y delta x work, because you really want to have that process down. So double check your work, see how you did. But notice line A and line C have the same slope, 1/2 and 1/2. So line A and line C are parallel. I know this because they have the same slope. That should be your solution. Alright guys, thanks for watching this video. I really hope you kind of caught on to that parallel lines. You can graph them, but you can also just look at their slopes to find the solution. And look forward to more videos. See you later.